Continue from the previous video. Here is the example 4. Find the volume of the solid of revolution formed when the region defined in terms of a line, which form its boundaries, is rotated through 360 degrees about x-axis. So here I have two questions. In question 4, this is A. A is having the curve y equals to 2x. So the region is bounded by this curve, the x-axis, and the line x equals to 1 and x equals to 3. First of all, I need to sketch the graph first. I got my y equals to 2x. Y equals to 2x is a straight line that will pass through the origin. This is a y equals to 2x. And this region is also bounded by the x-axis. The line x equals to 1. So the line x equals to 1 somewhere here. This is x equals to 1 and x equals 3. So this region that we're interested in is roughly located here. Okay, so this is the region that I shaded. And if this region is rotated about the x-axis through 360 degrees, so what is the solid that we can get? We will get the solid, something like that. And this is the axis rotation, axis of x. So when this region is rotated about the x-axis, you will get a solid like this. And now we're going to find the volume of this solid, which I will stick to the formula. Start from the pi and integrate from the value of 1 to 3 as a lower limit, upper limit, 1 to 3. The function, we should integrate the y squared with respect to x. Y squared means that is 4x squared, because y equals to 2x means that the y squared equals to 4x squared. Just put in the 4x squared into this integral, and we integrate with respect to x. Alright, so integrate as usual. The pi you should copy down, and you have a 4x cubed over 3. Integrate from 1 to 3. If the 4 over 3 you want to factor it out, you may do so. You can factor out the 4 over 3, then multiply by pi. So in the bracket, you just left the x cubed. You need to substitute the 3 into the x cubed now. That will be 27. 3 power of 3 is 27. Minus, substitute the 1 inside, you get this. Then you have a 26. Alright, multiply by 4 pi over 3. Which you have a 104 over 3 pi. And the unit is unit cube. Let's move to the question B. Now you have the curve y equals to x squared plus 1. Alright, so you need to sketch the graph first. Alright, this is the curve, which is y equals to x squared plus 1. And it passes through 1 at the y-axis. So you need to find the region. The region is bounded by this curve, the x-axis, the line x equals to negative 1 and 1. X equals to negative 1 will be here. And x equals to 1 somewhere here. Alright, so the region that we want is somewhere located here. Because this region is bounded by the curve, x-axis, x equals to 1, negative 1, and x equals to 1. So if this region is rotated about the x-axis, alright, rotate about the x-axis, so what kind of solid that we can get? Alright, so I'll sketch here, so that you can see roughly what is a solid that we can form. You will get something like that. And this is the axis of rotation. Alright, so if this region is rotated about the x-axis, you will get something like that, the solid. You want to get this volume, so now we just use the same formula. Start from the pi, integrate from the lower limit, negative 1 to 1, which you taken from the x-axis. And this function, the curve which is bounds this area is y equals to x squared plus 1. So you need to put the y squared inside. The y squared, then you integrate with respect to x. So what is your y squared here? You're going to put the y as a x squared plus 1. And don't forget, you need to square it. So before we integrate, we need to expand first, this one. You get an x power of 4 plus 2x squared plus 1. Integrate with respect to x. So integrate the three terms as usual. You have your x power of 5 over 5 plus 2x cubed over 3 plus x. Yeah, put in the limits. So now just put in the limits. Provide two big bracket. First bracket is for the substitution of the upper limit. You get 1 over 5 plus 2 over 3 plus 1. Put in the lower limit inside. You get negative 1 over 5 minus 2 over 3 minus 1. And the final answer is 56 over 15 pi unit cube. Just now we have the question, which the region is rotated about the x-axis. Now we have this example, which the region is rotated about the y-axis. The same thing we'll do, means that we need to sketch the graph first, determine the region, and then the region rotate about which axis we integrate. Alright, so sketch the graph. So I have this axis, x-axis, y-axis. Y equals to 3x is a graph that is a straight line, passes through the origin and it varies steep. So y equals to 3x. And now the region is bounded by this curve, the y-axis, and the line y equals to 3. So y equals to 3, you can sketch it somewhere here. This is y equals to 3, and y equals to 6. So you can sketch, you can just shade the region that you want. So when this region is rotated about the y-axis for 360 degrees, you will have the solid some sort like this. Yeah, okay, this is the solid that you have. So now we want to get this area, volume. Just integrate, start from pi. And now you integrate with respect to y because the region is rotated about the y-axis. And the limit also you need to take it from the y, that is from 3 to 6. 3 to 6. And the function which is bound this area, this region will be 3x. But since we are going to integrate with respect to y, you need to have your x in terms of y. Originally, is y equals to 3x. So now you need to convert x in terms of y. You have x equals to y over 3. And we need the x square, means that we need to square both sides. We have your y square over 9. Put in your y square over 9 here and integrate. So before I integrate, I would like to take out the 1 over 9. Then I need to integrate y square. Now, integrate your y square, you have your y cubed over 3 from 3 to 6. So now you just put in your upper limit and lower limit. Again, the 1 over 3, if you wish to factor it out first, you can do so. Factor the 3 out, you have a 9 multiplied by 3, you get 27. So now we just substitute the 6 inside, you get the 6 power of 3 minus the 3 power of 3. Because the 3, you already take it out, no need to consider anymore. So now, calculator, and you have your 7 pi unit cube. For the question B, the same method, the same flow, same process we're going to apply, but now it will be a different curve, is your x squared minus 2. So it's a quadratic curve, just sketch your, if you know how to sketch your y equals to x squared, you just shift your graph of y equals to x squared downwards for 2 units, you get your x squared minus 2. Alright, here's the graph of y equals to x squared minus 2. From the y equals to x squared, just go downward for 2 units. You get the x squared minus 2. And now you have the region which is bounded by this curve, the y-axis and the line, y equals to 4. So y equals to 4, you can have it here. This is your y equals to 4. And now the region will be bounded by this curve, y-axis and y equals to 4. So is it y-axis? Yeah. Alright. So just shade the region that you want. That will be the region. For this question, you either can shade this side or the other side, left-hand side. It's okay because this graph is just symmetry about the y-axis. When this piece of the graph, this piece of the region rotate about the y-axis for 360 degrees, you will get this solid. Just sketch the eye shape. You will get the solid like this. Alright, the solid that you want is here, all this. Alright, this will be like this. Just like a cap. Okay, this is your axis of rotation, y-axis. Now we're going to get the volume of the solid. So again, this volume is actually generated by rotating about the y-axis. We need to integrate with respect to y. And the limit we also need to take from the y-axis. That will be -2 from -2 to 4. And the function, we need to get it, we need to put the x squared over here. So you have a y equals to x squared minus 2. To get the x squared, you just move the -2 or you just add 2 at both sides. You have your y plus 2. So this already in terms of x squared, right? So we just put in the x squared as a y plus 2. That's it. And integrate this with respect to y. Okay? So integrate, you will have a y squared over 2 plus 2y. Put in your limit. Have your bracket. Four put in, you will have a 16 over 2 for the first term. You got a 4 multiplied by 2, you got 8. -2 put inside, you have 4 over 2, that will be 4 over 2. Alright, minus 4. So now calculate with your calculator, or you may just calculate because simple, right? 16 over 2 will be 8. 8 plus 8, 16. Alright, 16 minus, this is 2. 2 minus 4 will be a -2. -2 multiplied by negative, you got +2. So finally, you have your 18 pi. Unit cube.